Okay, so this video is going to be for my air rocket activity, and so I'm going to be going through problem numbers 1 through 10, and then this is problem number 1 where we had to sketch a diagram, and yeah, these are the 4 position versus time graphs which I drew. This one's for low, and then this one's for medium, that one's for high, and that one's for super. And then this arrow represents the positive direction, which I said is up, and then going downward is the negative direction. And yeah, so that's number 1. Okay, so for number 2, we have to draw velocity versus time graphs and acceleration versus time graphs, and then it's basically showing the speed of the rocket as it's going through the air. So top one's velocity, bottom one's acceleration, and yeah, that's problem number 2. Okay, so number 3 asks what's the change in velocity, and I said that the change in velocity is negative 10t because that's the area under the acceleration graph, and the area under the acceleration graph, I think it equals the change in velocity. So beneath that, I plugged in different times for low, medium, high, and super, and then I got my change in velocity, and that's basically number 3. Okay, so problem number 4 asks how fast was the rocket traveling when it was launched, and how do you know? So for this, I said that the slope equals the rise over run, and then the slope of the velocity versus time graph is negative 10 meters per second squared, because that's for the acceleration graph too, and the acceleration graph, or the acceleration is the slope of the velocity graph of the line for the velocity, the slope of the velocity. I don't really know. Okay, so I got an equation which is negative 10 equals negative 2 times the initial velocity over time. Yeah, that's the equation, and then I plugged that in for low, medium, high, and super, and then I got my initial velocity, and that's how I did problem number 4. Okay, so problem number 5 asks is the speed when the rocket was launched different from the speed just before the rocket hit the ground? Explain your logic. Um, the speed of the rocket, I thought it was the same as before it hit the ground because, well, the acceleration was constant, so both had the same amount of time of the same acceleration. That's what I thought for number 5. Also, when you think about it, when the rocket was released, it must have had the highest speed, and then when it was going down, just before it hit the ground, that must have been the greatest speed for the rocket. So I'm guessing it would be the same, not different. So it wouldn't be different at all. I guess it was been the same, yeah. Problem number 6 asks what was the maximum height of the rocket? And then, so to get that, we have to get the area of the triangle and the velocity time graph. I didn't actually show it in this problem, like for number 6, but I have an equation so you guys can do it. The equation is area equals initial velocity times time divided by 2 or times 1/2. And then, so I did that for low, medium, high, and super. I plugged the initial velocity and the time, as you can see, and that's how I got my area. And that all of these equal the maximum height, right there. And that's how I did number 6. Okay, for number 7, the problem asks, was the acceleration different when the rocket reached maximum height. It actually was not different because we know that the acceleration is constant, and since for all the velocity versus time graphs, since we know that they all had negative slopes, um, the acceleration must have been constant, so it wouldn't have been different at all. And that's number 7. Okay, problem number 8 asks, what was the total distance when that the rocket traveled? Um, so what we have to do is multiply the initial velocity with time, and I did this for low, medium, high, and super, and basically that's what I did for problem number 8. And then for problem number 9, that asks, uh, what was the total displacement of the rocket? Displace. Oh, I spelled displacement wrong. Displacement for all the rockets. Well, basically it was 0 because um they all start at a position and they all ended at the same position. So the positions were basically the same. So that's why it was 0. Um, yeah, that was problem number 9, and then problem number 10 that asks, are your answers different for the last two questions? Why? Um, the answers are different because displacement. Wow, I spelled it correctly over here. Okay. The answers are different because displacement asks to subtract the original position from the final position, which in this case is 0, whereas the distance explains how far the rocket traveled. Displacement doesn't actually say anything. It's just you gotta look where the rocket started and where it landed. So you have to look at the position, and which in this case is 0, and the distance has to be um during, I don't know, well, where, uh what did I say? Oh yeah, distance explains how far the rocket had actually went. So yeah, that's problem number 10, and that's how I did my air rocket activity. Yeah, I'm done.